Yes, good morning, students. In the chapter number 8 of a physical and chemical change in part 1, we had already studied about that what is the difference between physical and chemical change. Today, we are going to discuss about the types of chemical reactions. Okay, students, we have seen that certain patterns are observed in chemical reactions. Chemical reactions are therefore grouped according to their patterns. So these makes the study of reactions easier in the same way as the classification of plants or animals make their studies easier. Okay. So when we are classified all the chemical reactions individually, so we can easily identify the reactions. Okay. So by using these patterns, we can predict the products formed in a large number of reactions. So some of the important types of chemical reactions are here. So what we have seen, students, we have seen on the screen that there are the 5 types of chemical reactions are there. First one is synthesizes. Okay. Second one is decomposition. Third one is single replacement. Fourth one is double replacement. And the fifth one is combustion. Okay. So these are the 5 types of chemical reactions are there. Okay, let's see synthesizes. Okay, first of all we are going to discuss our first type, that is synthesizes. The word synthesizes means to put things together to make a whole. It means that we keep all the things together to make a whole. Okay, so what happened in the synthesizes reaction now? In a synthesizer reaction, two or more chemicals bond together forming one new substances. Understand, students? So in this synthesizes reaction, what happened? Two or more chemicals they can bond together and forming a new substances. Okay, so that is called our synthesizes reaction. Let's see with the help of example. The get minus together. Okay, it means that reactant A is there and reactant B is there. When they combine together, what they form? They can form a product, and that is called AB. It means that in synthesizes reaction, what happened? We can say that it is a combination reaction also. Okay, so when a compound is formed from its element or from a simpler substance, that reaction is called our combination reactions. Okay, so when we take A and B, what they form? That form the AB. Let's see by the diagrammatic representation. They can also giving you the brief. One boy is there, one girl is there. When they combine together, what they form? Boy girl. Okay, so these type of reactions are known as our synthesizes or combination reactions. Okay, students, when two chemicals combine together, then they can form a product. They are known as our synthesizes reaction. Synthesis reactions are easy to recognize. There will be two or more reactants, but only one product is there. See, by the help of example, Na, one element is there, and Cl, that is another reaction, another element is there. When they combine together, what they form? NaCl, sodium chloride. It means that salt. Okay, so what we see in this example, that when two elements are combined together, so what they form? They can form a new substance. Same in the case of H2O also, in the case of water also. Two atoms, hydrogen and oxygen, when they combine together, they can form a molecule of water. Okay, so this type of reactions are known as our synthesizes reaction. Our second type is decomposition reaction. Okay, so the word decomposition means to separate. What is the meaning of decomposition? Decomposition means to separate or break down into smaller pieces. Okay, what is so in a decomposition reaction, one substance breaks. Okay, what happened in this reaction? Just opposite. just opposite of the combination reaction or synthesis reaction. What happened? In a decomposition reaction, one substance breaks down into two or more products. Let's see. Yes, this one, the breakup. Reactant is there, okay? So one reactant is there, and when they separate out, that is called our decomposition reaction. Reactant is there and product plus product. It means that the reactant is split into two types of product. See, by the help of example, decomposition reactions look for chemical equations which have only one reactant but two or more products are there. See, first of all, the example of water. We have a molecule of water, S2O. S2O, when it split down, when it separate out the products, what, one hydrogen and one oxygen product is there. Okay, so what is this? The molecules of water. The molecules of water is splitting into what? Hydrogen and oxygen. Okay, so this one is our the splitting, and that is called our decomposition reaction. So decomposition reaction is one in which a compound breaks up into two or more substances. Okay, AB is there, and when it splits into A plus B, that is called our decomposition reaction. Now see student, replacement, it means that something placing something is there displacing happened in this reaction, in this type of reaction, single replacement reaction. So in that we can see that one element replaces another element in a compound. Okay, so one element can take place the position of other element, or we can say that a more reactive element replaces a less reactive element from its compound. Okay, let's see with the help of example. Reactant plus reactant gives product plus product. It means that one reactant is R, that is AB, and the second one reactant is there are X. So what they form? So in this one, in the reactant part, which one is the stronger one, which one is the more reactive element, it can take place the position of less reactive element. It means that after this, what product happened? AX. It means that what the A has to be replaces the B. Okay, so in this case, what happened? The most powerful elements can replace the less reactive elements. Okay, single replacement reactions have an element and a compound on both the reactant and product side of the equation. See, with the help of example, Zn, one reactant, then HCl is another reactant. Then what they form? ZnCl2. Okay, and hydrogen is split has to be evolved out. Okay, so this type of reactions we can say that it is a single replacement reactions. Okay students, understand it? Now we are going to discuss about our double replacement reaction. Same happened in that single replacement is there. In this one, a compound reacts with another compound to form a new compounds. Let's see. Double replacement reactions have two compounds on both the reactant and product side of the equation. AgNO3, one reactant, and the other reactant is NaCl. When they combine together, what they form? AgCl, the most powerful element can replace the other one, less one, AgCl, okay, and NaNO3, okay, sodium nitrate. Then we know about the neutralization. So what the student double replacement? In double replacement, we see that the double elements can replace the lesser elements position. Okay, sir. Okay, students. Thank you so much.